what volume of carbon dioxide CO2 at STP would be obtained by reacting 10 centimeter cube of 0.1 molar conc solution of anhydrous sodium triisocarbonate 4 with excess acid. Now, you need to first note they said sodium triisocarbonate 4, right? So you write your equation down. Na2CO3. Now, please note, whenever you react a carbonate with an acid, you get a salt, carbon dioxide, and water. Now, in this case, they said react sodium carbonate 4 with excess acid. They didn't tell us the acid, so we are just going to make use of hydrogen ion. So it's 2 hydrogen ion here. So this represents our acid. Since they didn't say HCl or H2SO4 or HNO3, we'll make use of that. Now we are going to be would get the sodium salt, but this time around it's being in form of ion. Na2 here plus would still get water, H2O, and would get CO2, okay, carbon dioxide. And from our question, we are asked to solve for the volume of carbon dioxide at STP. Now, this is the first step. This equation is balanced. Now, let's bring out our mole ratio. The 2 here is this 2 here. There's nothing, so I'll indicate my ratio to be 1 here, 2 here, 2 here, 1 1. But pay attention, we are only asked to solve for the volume of carbon dioxide, so we are only going to consider this one and this one, okay? Now we will consider. So we'll go further. We'll go say 1 mole of this point would stand for the full stop of Na2CO3 Na2CO3 would give us 1 mole of CO2. Would give us 1 mole of CO2. How do I know 1 mole of CO2? Here's the mole, 1. Okay. Now the next step is we'll solve for mole, making use of the note we're giving volume here, and we're giving the molar conc of sodium triisocarbonate 4. So the next step, let's solve for the mole of sodium triisocarbonate 4. So mole is represented as this of Na2CO3 would be molar conc times volume. In this case, our molar conc was given to be 0.1 from our equation, times 10 was given, and the 10 here is in centimeter cube, so I'm going to be dividing it by 1000. Since they put them in centimeter cube, you could divide them by 1000. Say they give you in dm cube, there will be no need to put this 1000, okay? So if you punch your calculator, you get 0.001 mole. Don't forget, this mole now is the mole of sodium triisocarbonate 4. But what our question asks is for us to solve for the volume of carbon dioxide. But first, we'll solve for the mole of sodium triisocarbonate 4, which is this. Next, we'll solve for the volume of carbon dioxide now. So I would say volume of CO2. And the formula to use here is that number of mole equals volume at STP. So our number of mole here would make use of this one that we've solved. You say 0.001, okay, times what our volume? Our volume was given to be 22.4 dm cube. Now if you multiply this, you would get 0.0224 dm cube. Now if you want to convert this to cm cube, you just need to multiply here by 1000, and you would likely arrive at 22.4 cm cube. Let me write my cube, cm cube. Now let's go back to check our options if we have such an answer there. Yes, option B is the correct answer. 22.4 is in cm cube here rather. Okay, sorry, 22.4 cm cube. This, we multiplied it by 1000 to get cm cube. That's from dm cube. So from dm cube to cm cube, we multiplied by 1000. So it's 22.4 cm cube. So option B is the correct answer. If you've watched to this point and this is your first time, please do well to subscribe to the channel, and next I'll leave a task, just like an assignment for you to solve and complete. So this is the task. You just have 2 tasks. Solve these 2 questions for me, snap and submit on the WhatsApp group. Now, if you're not on the WhatsApp group yet, I'll leave the link to the WhatsApp group in the description box. Thanks for watching. I'll see you in the next video.